In this video, I'm going to show you how you can simulate a cycloidal reducer mechanism in under 5 minutes completely from scratch inside ProtoTwin. The process for creating any model in ProtoTwin always begins by importing the CAD. For this model, I'll import the main assembly for the cycloidal reducer mechanism from Onshape directly into the simulation environment. Before we begin adding components to the various parts, notice how the casing on the outside of the mechanism is blocking our view of the interior. To hide a part, I'll first select the casing entity. Then, in the advanced category of the graphics component, you can toggle the visibility option, which will hide the entity from being shown in the viewport. Alternatively, you can right-click on the entity in the Explorer and then toggle the visibility of that entity from the context menu. We can now begin adding components. I'll first select the eccentric shaft entity, then add a physics component with the collider set to none, since we're not interested in modeling collisions between this part and any other parts. I'll now add a joint, set the constraint type to revolute, then configure the axis and anchor properties by selecting appropriate features from the CAD. This will constrain the shaft to rotate about the y-axis and around the anchor point we selected. I'll then add a motor component that will drive the joint and set the controller to use velocity control. We can leave all the other options on the motor to their default values. I'll now select the roller pins entity in the Explorer. If we expand the entity, you'll see that there are 10 children. Instead of adding a physics component to each child, we can add a physics component to the parent with the collider left as convex. This is acceptable to do because the convex collider creates a convex hull around the graphics mesh for each descendant entity. Finally, to prevent the pins from falling, since they're fixed in place, we can set the body type to kinematic. Kinematic rigid bodies do not experience external forces like gravity. I'll now select the cycloidal disk entity and add a physics component to that entity. I can then add a joint and set the constraint type to revolute. I'll now configure the axis and anchor properties for the joint just like we did earlier. However, even though this joint does not need to be driven by a motor, we do need to set the base property of this joint to the eccentric shaft. This constrains the cycloidal disk to rotate about a plane relative to the eccentric shaft. Finally, since the geometry of the mesh contains holes, we will need to generate a custom collider. Upon choosing a custom collider, the mesh will be downloaded directly into ProtoTwin's custom collider tool. I'll now set the collider type to SDF and configure the resolution and thickness properties before generating a signed distance field collider. When you're happy with the collider, you can click the Save button, which will upload the collider from the tool and download it back into the main application. I can now select the pin disk entity, then add a physics component. I'll then add a joint, set the constraint type to revolute, and configure the axis and anchor properties by selecting appropriate features from the mesh. For this part, I'll once again generate a custom collider. The graphics mesh will then be automatically uploaded and downloaded into the tool. For this part, I'll leave the collider as multi-convex and set the concavity threshold to 0.02. Upon generating the multi-convex collider, you will notice that there are 155 convex hulls. Since we're not interested in modeling collisions anywhere except the pins near the bottom, we can click the Edit button in the toolbar to edit the collider. I'll now select the convex hulls for each of the 9 cylinders underneath the mesh. Once you've done that, you can right-click and then select Invert Selection. Now I'll click the Delete button at the bottom, which will remove all the convex hulls except the 9 we selected. I'll now click the Check button and then click Confirm to confirm the changes we just made. When you're happy, you can then click Save again to upload the collider from the tool and download it back into the simulation environment. You can enable physics visualization to check whether the simplified collider has been imported correctly. Fortunately, everything looks good. When you're ready, you can run the simulation to test your model. And that's it. A working cycloidal reducer created in ProtoTwin in under 5 minutes. I hope this short video gave you a better idea of how to configure the physics, colliders, joints, and motors to create a dynamic digital twin of a cycloidal reducer using ProtoTwin Simulate. Thanks for watching.